Alright, the first one is just an equation. Be careful when you distribute with your negatives in here. Electrolyte terms and solve. Are there any domain restrictions in that? No. What gives us a domain restriction? A radical, a fraction, and a radical under a fraction. Good, there's 3. Good. Good. Anything else you're okay with? It means any x you can plug in there. Always go, your folders are here, and I put everything in by the date. If you take one of each. One we did in class and one we did for review. Alright. Number 2, this one's the long one. The rule, always isolate the radical, isolate the absolute value. So isolate your radical. Get it to one side. This is key, guys. When you do this right here, you have to work this out. You have to do 2 minus this times itself, not its conjugate. So yes, you come out with a middle term. You can't square both terms because this is a binomial. And they're not conjugates. It's the same term. So you've got to do this out. This gives you minus 2, minus 2, minus 4 of these guys. And a negative times a negative is positive, and now it comes out. Electrolyte terms, isolate your radical again. If possible, divide by the negative 4, but it's not, so leave it. When you square this, don't forget to square your negative 4 as well. Now, if you notice, every time you do this, when you square this, you've changed your radicals around a little bit. You're forcing a negative to become a positive. Whenever you move your radicals from side to side and you square your negatives, you're actually bringing it out as a positive. So you definitely have to check your work, because what ends up happening is it may not work. And again, we checked them at the end, and they were both rejected, and then therefore no solution. Sure.
After the first line, what happens to the 8?
What happens to the 8? This one combines with this, right? And this combines with this. Collect your like terms before you move anything. If it helps you, put a line down your equal sign. It's a small thing to do, but it kind of helps you from just gathering all your things together. Any questions on number 2? You know you're going to see one of those. Isolate your radicals, square both sides. Now, these have a domain restrictions. Where are our domain restrictions here? Under the radical. So let's talk domain restriction. 2x plus 3 has to be greater than or equal to 0. And x minus 2 has to be greater than or equal to 0. It has to be true for both of these. So we subtract 3. And you're still dividing by a positive, so nothing changes. Here's your number line, negative 3 halves. This guy, add 2. And so at the 2, so what's going to be your restricted domain? It has to work for both. If you use this one, if I put a 0 in here, 0, this one won't work with 0. So you have to use where they overlap. Your restricted domain is where they overlap. But both of these values were in your restricted domain. You still have to check to make sure they work with the radicals. Absolute values and radicals you have to check. Because you manipulate those, you square those. When you're squaring something that has a negative in front of it, chances are something's going to go wrong. So remember your restricted domains. Radicals have to be positive or 0 in this case. Questions? No? Okay, absolute value. Absolute value has the same exact rule. Isolate your absolute value. The absolute value is isolated. When you do an absolute value, do a small one. Just go like this. This says, oops, x can be negative, x can be positive 3, or x can be negative 3. That gives you two roots to take. So you know you have to have two paths. The positive path, everything stays the same. The negative path, whatever is here, negates. If it's two terms, parentheses, negate. And then you solve. And again, you have to check. Just because the answer is negative doesn't mean it's going to be rejected. It just so happens the two negatives in here were rejected because it's all by itself over here. So if you're putting a negative, if any absolute value is equal to a negative, not going to happen. So that's why your negatives were automatically rejected. See it? But if there's anything else there, if there's x plus 2, you have to make sure you check it. Questions? No? Everybody can do these? Yes? Good. This is exactly what your test is going to look like. One of each of the major things that we did. Here's your inequalities. Here's a quadratic inequality. Everybody likes the quadratic inequality. And we noticed yesterday that whenever a quadratic is under a radical, it gives us a quadratic inequality. That's where they come from. So we set it equal to one side, get everything to the left. Oops. Oh. Get everything to the left. Factor, set it equal to 0. You're finding the zeros, the roots. This is like your x-axis, your number line. So we found out where our roots are. It's greater than or equal to, so they're filled in. Your quadratic is opening up. If not, put this little piece in your y equals. And check. To the left, in the middle, to the right. You want the positives. Quadratics are nice. Just remember, if it's negative in front of the x squared, if a is negative, it opens down. If a is negative, it's going to open down, but make sure when you find your roots that you divide by your negative, because your roots are going to be the same. Your zeros will be the same. It just will open the opposite way. And number 5 is your rational. Zeros are the numerator, zeros are the denominator. Everything has to go to one side. Yeah, and you have to find a common denominator. Everything is on one side in this case. It's already on one side. If I had equals 3, I'd have to move the 3 over. I'd have to find a common denominator. Everything is okay the way it's set up. So zeros of your numerator and zeros of your denominator. Your denominator is what gives you your restriction. Says, I can't use a 3 in my denominator. That's a restriction. So that's the one that's always going to be the open circle. The top one is based on whatever your inequality says. And test it. Put it in your y equal and test it. This one is more difficult to figure out where it's coming from because there's breaks in your graph. It's not continuous like your quadratic is. That's a nice one to be able to do that one. Questions? Look. And then I just moved it and moved it back to where it was. Good. This is a tough one. This is a challenging one. You cannot cross multiply your rationals. You get everything to one side, you find the common denominator. All you need to do when you look at your common denominator is figure out what factors they both have. I need an x plus 1. I need an x minus 1. If it helps you, right next to this, there's no equal sign. So you cannot multiply out and get rid of it. Just put it top and bottom because that's the same as 1. So now my denominators look good. There's my numerators right there. What catches you is this negative sign. Watch the negative sign. So collect your like terms in the numerator. Bring it down to here. And your 2 factors in the denominator. This is where your domain restriction is. X cannot be plus or minus 1. That's also your zeros of your denominator. That's going to be open on the plus or minus 1. And your zeros of your numerator was x is equal to 5. Oh, sorry, negative 5. So that one's closed because of that sign.
Did you know stable in this first line, x minus 1 or x plus 1? How about that?
This?
Yeah.
Because from this, we needed a common denominator. We need a common denominator. Like if you had this. We need a common denominator. So, does 3 go into 5? So what would your common denominator be? 15. So I'm just going to write it like this. Now to get 15, this needs to be multiplied by what? 5. So does the top. So 5 times 1. Minus. To get 15, this needs to be multiplied by 3. So does the top. Minus 3x. Yes. Yes. Each term. You're taking each term and converting it to match that denominator. So I find it easier if you look at it like this, and then you say, oh, this needs an x minus 1, top and bottom. Now I know what to multiply my numerator by. Same thing with this. This needs the x plus 1. And now I can multiply my numerator by that. It's the same thing. Fractions don't change. It's the same rule for all your fractions. Collect your like terms. It takes a little bit longer to collect them. And zeros are the numerator, zeros are the denominator. Again, when you put this in your calculator, your first y equal is this one right here. Now that I made a mess out of it. This is your first y equals when everything is on one side. Don't use an inequality sign. Just use the equal. And then put this one as your y2. Because if this is right, then you did everything that you were supposed to do. If the graphs are different, then something went wrong. And use your fraction bar when you're in your y equals. It's far better than putting parentheses because you would need a separate parentheses around those denominators. Otherwise it will drive you crazy. If you don't put it there, and it graphs and it's not the same graph, you're going to spend a lot of time figuring out what you did wrong when you really didn't do anything wrong. Good? This is a tougher one. But this is what you're able to do. Somebody's breakfast? This is an equal sign. An equal sign says, find a common denominator and get rid of all your denominators. Find your domain restriction first. It won't have my writing on it, but it'll be there. Alright, find your domain restrictions. You said a fraction cannot be 0. Set whatever's in the fraction in the denominator equal to 0. Take it out of your domain, and you are left with your restricted domain, the ones you are allowed to use. So when you come down here and you get your answer, you go back up and you say, oh, my domain says from negative infinity to 2, from 2 to 3, from 3 to infinity. Can I use a 5? Yes. This is the domain. This is the solution. There's a difference between those, right? Thomas. We got rid of your denominator. So we multiplied every term by t minus 3, t minus 2. This one too. This one too. And this one, it's both of them. So what happens is this cancels out. And we're left with just 10.
So you don't do that for inequalities, then?
No inequalities? No, you can't. Inequalities, you don't find the solution. You can't work them that way. Because you can only do that when you have an equal sign. Okay, so collect your like terms and solve. Number 8, how did we know we couldn't factor this? Because we did a times c. 3 times 2 is 6. Are there factors of 6 that add up to 6? No. So we couldn't factor this. So when you can't factor, quadratic. Everybody remembers their quadratic? Yeah? Everybody remembers the factor with a times c? If a is greater than 1, use a times c. Questions at all? Be careful on this part right here. Don't cross out terms. Factor, and then factor out to get the 3. You can also separate this like this if you wanted to. And then reduce it. You can do that if you like. Or actually you could leave it like this if you like, because it can't be reduced any further. Don't cross out terms. Make sure you also reduce all radicals to its perfect square and not so perfect square. Good. Did you guys learn the quadratic in Algebra 1? Did you guys start the Common Core Algebra 1? No. Now they're learning the quadratic in Algebra 1. They're also learning complete the square in Algebra 1. Yeah, I think that's pretty tough for those guys. Yeah, I sure can. Okay, the last one again, this was your radicals. You could move either side of your radicals. Isolate your radicals, square it. Again, find your restricted domain. Let's find your domain for this. I have a problem under my radicals. X has to be greater than or equal to 0, and 2x plus 1 is greater than or equal to 0. So this one's good. I'm going to subtract 1 and divide by 2. So this one says negative 1/2. So what's my restricted domains? Were they overlap? So what will it be? 0 to infinity. Good. And just because they come out in our domain, you still have to check. There's your extraneous root. Your extraneous root says it works. This is my root, but when I put it back into my situation, it doesn't work. What happens when you square a negative part of a radical, sometimes you mess with your radicals a little bit. Good? Well, you got to isolate your radicals. I found it easier to move this guy. Add it to that side, right? Yeah. Now square both sides. This is a monomial. This is a binomial. There's the difference. This guy, I can say 2 squared radical x squared. This guy, I have to write out It's a binomial. And they're not conjugates, they're the same pairs. And just do your distributive property. 1, then 1 plus this mess, and another 1 plus this mess, and the last one is 1. Combine these, and 1 and 1 gives you 2. So plus 2 of these guys. And then isolate again. Get everything to one side and isolate again. Oh, don't forget your 2x plus 1. Sorry, 2x plus 1. I left out my 2x. And your 2x. Okay, so make sure you do it again. You have to repeat. Always remember, isolate absolute values, isolate radicals.